Okay, so and the first one we'll learn is chain rule, and chain rule is actually on the textbook. So that's 20A. So any 20A, 20B, 20C, you can use those three exercises doing homework. You can do the practice on textbook. And after that, the product rule and quotient rule, I'll provide you some extra worksheet because it's involved in year 12 and don't have suitable questions for year 12 books. So I will give you some worksheet to do practice. But for the first three exercises, you can use the textbook you have now. Okay, for chain rule, what is chain rule? You can think about this. It's not really true, okay, but you can think about this way. dy dx is dy du. U is another variable, okay, u is another variable, and times du dx. It's quite a lot I need to go through for the chain rule. So dy dx is dy du times du dx. You can think it's two fraction times together, and the du and du will get cancelled. You can think in this way, okay? This is the basic idea for chain rule. Okay, that's the basic idea for chain rule. So you introduce another variable, and then that variable will get cancelled when you do the times the two fractions. So this is chain rule. What is actually how we use it? Okay, let's think about y equals to, you don't need to copy this, okay, I just rewrite it. It's everything listed here. This is the steps. So find the derivative of y equals to blah blah 3x squared plus 1 to the power of 3. What's the method we used before to do the chain, to differentiate that? What's the method we used before? Expand, right? Expand. But think about expanding this, it can be very tedious, right? Well, if it's not to the power of 3, if it's to the power of 5, it can be almost impossible to expand without calculator. Very hard process. So what we can do now is y equals to this. And now I want to introduce a new variable. We make y equals to u to the power of 3. We introduce a new variable. And then u equals to what? U equals to this. What I want to find is dy dx, right? What we're trying to find is dy dx. But what we can do by using chain rule is we introduce a new variable. We can use dy du times du dx. Okay, that's the idea. We introduce a new variable to simplify the calculation steps. Okay, to simplify the calculation steps. What's dy du, everyone? But you want to find dy du, you need to find the relationship between y and u. So y equals to u cubed. What's dy du then? Yeah, 3u squared. Okay, dy du equals to 3u squared. Times, what's du dx? You need a relationship between u and x. 6x, right? 6x. That's your dy dx. Your dy dx equals to 3u squared times 6x. What's u? I don't want u, I want x. U is something I create. I want to make it back to x first. So what's u? 3x squared plus 1. So what I have is 3 times 3x squared plus 1 to the power of 2 times 6x. Then what we can do is do any calculation we need. That's this. Well, I don't need to expand. Okay, I don't need to expand. If I expand, that will be the same result as your expand and then derive, but I don't need to expand. Just leave it like that. It's a quite like factorized form. It's quite simple. Okay, so what's the idea for chain rule? Okay, chain rule is when we can't derive something directly, okay, or it's very hard to derive that directly, I want to introduce a new variable to replace that by some complex calculations and then simplify the way we can differentiate. So for example, this is something to the power of 3. But if I can make this something become a single variable, like a single variable u, it's very easy to differentiate. U to the power of 3 is very easy to differentiate. I don't need to worry about the x. So dy du is just 3u squared. But an u equals to 3x squared plus 1 is also very easy to differentiate. I don't need to do expanding or like anything. So I can find my answer easily without expansion. So this is, well, because we haven't learned all the other rules, we just learn polynomials. That's the only way we use for polynomial. Okay, that's the only thing we use for polynomial. Basically, all the things will repeat it by this way. But what I want to say is, you don't want to do all these steps every time. You don't want to say, okay, let u equals to that, and then dy du equals to that, du dx equals to that. At times, then I replace u back. I want to show you 2 quick results. Okay, I want to show you 2 quick results. What's the 2 quick results? Formula 1 and Formula 2, they all come from the chain rule. I can show you, okay, I can show you why. But I want you to remember those 2 results. The first one, I think you're not familiar with this notation yet. If y equals to f of gx, which means I put gx into the function fx. This is called a composite function. So for example, what we can think about for y equals to 3x squared plus 1 to the power of 3. I can think about my gx equals to 3x squared plus 1. I can think about my fx equals to x cubed. Now y will equals to f of gx. Okay, you will have the same result. I put this function into the x cubed function, I will achieve the same thing. Okay, I put gx into fx, I will have what I got at the beginning. So this is called a composite function. But like, you don't really think about that way. Okay, you don't really think about this. This is very limited use. I will show you when do we use this one, when we use that one. But what's the dy dx equals to? The dy dx equals to what? Well, equals to, we derive the inner function g dash x, and times we derive the outer function f dash, and we still put gx in. Okay, that's the result of derivative. What I want you to do with this formula is memorize it. Okay, memorize it. This is something you need to memorize. You don't need to ask why. I will show you how to use it later. I can show you why. Okay, so it's very similar idea. Because y equals to f of gx, I can make u become gx. Then y will equals to fu. Okay, y will equals to fu. So what's dy dx? Dy dx equals to dy du times du dx. If you think about what's dy du, it's just f dash u. Okay, dy du is f dash u. What's, if you have fx, what's the derivative? Is f dash x. So you have fu, what's the derivative? Is f dash u. So it's just f dash u. What's du dx? Du dx is g dash x. Okay, dy du dx is g dash x. What's f dash u? F dash u is f dash of gx times g dash x. Okay, that's how we get this result. That's how we get this result. Why we have g dash x times f dash, and then we put gx in. But there's very limited use of this function. You need to just remember it. Okay, I don't want you to use u every time to find out the formula by yourself. So I want you to remember the result directly, and when you need to use it, you can use the result directly. I have an example here. Like, this is the example how we use it. Okay, example 3 is the example how we use it. I will go through that with you later. But if you have a function f and you put some function in it, how do we derive it? We derive the inside function first, make it become g dash x. and we derive the outer function. We put the inner function into the derivative of the outer function. So that's how we find the derivative. And why? I have shown you why. It's very easily just use chain rule. Okay, just use chain rule. The second one is a very, very, very important one because, as I said, I don't want you to use U again and again and again. I want you to directly remember the result. So what's the result? This one is relatively easy. 3 steps. If you have a function to the power of n, okay, this is a function to the power of 3. Satisfy what we have. Okay, a function to the power of n. So something to the power of 3. Satisfy that. What's the derivative of that? 3 steps. First step is, remember what's the derivative of x to the power of n, everyone? N, x, n minus 1, right? So we times the n and then we reduce the power by 1. Very similar 2 steps here. We still times n. We still reduce the power by 1. Whatever function you have, we reduce the power by 1. But we have one more step, is derive the inner function and then times it. 3 steps. We times the n, we drag the n down, we reduce the power by 1, and then we times the derivative of the function inside. Okay? The sum gx to the power of n, we derive the gx. We just create one more step. This result comes from chain rule as well. Okay, this result comes from chain rule as well. Why come from chain rule? Just show you here. Equals to gx to the power of n. If y equals to gx to the power of n, I want to find dy dx. I make u becomes gx. Y will becomes u to the power of n. Okay, y become u to the power of n. So dy dx equals to dy du times du dx. Okay, dy dx equals to dy du times du dx. What's dy du? N times u to the power of n minus 1. What's du dx? What's du dx? G dash x. Yeah, g dash x. That's how we get the derivative of the inside function, g dash x. And now remember to put u back into x. So it's n times g dash x times gx to the power of n minus 1. Okay, to the power of n minus 1. What all I have talked about so far is all the same thing. dy dx equals to dy du times du dx. But why I have give you 2 separate formula is because I want you to remember the result of that formula, and you don't need to use u every single time. I don't want you to say, oh, u is that, and then dy du is that, du dx is that, and then convert u back into x. Like, it takes a long time to use that. If you can remember the result directly, we can just directly apply to the question and then work out the derivative. Yeah, work out the derivative. Yes?
You said that u equals g of x. Why don't we put it back into the function?
Oh, you want u is something you created. Your final result shouldn't involve u.
Yeah. So when you you said u equals g of x.
Yeah.
So when we put it back, when we replace
yeah.
u with g
yeah.
of x, and g dash.
No, gx. I swap the order.
Oh.
Yeah, gx. I put n first and then g dash x and then u back to gx. Yeah. Okay, how we use that? We can look at example 1, how we use that. Y equals to that to the power of minus 2. Okay, this is gx. Can you think about that? That's gx. That's gx to the power of n. Yeah, that's in the same form. Gx to the power of n. Okay, I want to find dy dx. 3 steps. What's the first step? Okay, n. What's n? -2. So we first write -2. Times. It's three things times together. What's the next thing? Okay, what's g dash x? 12x squared minus 5. That's my g dash x. Times a third thing. What's that? Okay, so gx is 4x cubed minus 5x to the power of -3. Yeah, that's the result. That's the result. Well, if I want, well, I can leave it like that. Or if I want to make it looks better, I can make it looks like that. Just make the negative power become the reciprocal. Okay, next one. Next one. Find the gradient of the curve with this equation. What you want to do first to this equation is 16 over 3x squared plus 1. What do you want to do to that equation? If you want to derive it. Before you want to derive it, what do you need to do? To the power of something. So y equals to 16 times 3x squared plus 1 to the power of what? -1. Okay, still this is something. This 16 is the number. I don't need to worry about the coefficient. It's something to the power of -1. The something is this, the gx. And this is n. Okay, the power is the n. 16 is just a coefficient. You know, like the coefficient will just stay there. So you don't need to worry about the 16. 16 is there. Okay, first step, what do you need to do times? N is -1. And what do you need to times? 6x. Okay, the derivative of gx. And what else do you need to times? 3x squared plus 1 to the power of -2. Reduce the power by 1. So if I can rearrange that, -96x over 3x squared plus 1 to the power of 2. That's the dy dx. And just a little bit revision, I'm not sure if you still remember. dy dx represent the gradient at any point. Okay, the gradient at any point. dy dx is the gradient at different x values. So how do you find the gradient at x at the point 1, 4? We sub x equals to 1. So dy dx equals to -96 over 16. And that equals to -6. Okay, very easy. Just another technique for you to derive. Okay, another technique for you to derive. When we learn this, I don't need to expand. I can just easily derive everything. Okay, with the power, like any power function, very easy to get derived. Okay, just show you the last example. Okay, this one I think might be a little bit early for you, but like I still want to try if you understand it. This is called a composite function. What is a composite function? Hx is you put function gx into the function fx. We have talked about that before, like we want to find what's the rule for f of gx. But like the name of this type of function is called a composite. We combine two functions together. We put one function into the other function. It's called a composite function. Let's have a think about the easy one. So for A, I want to find H2. First of all, what is Hx? Hx given us is f of gx. Okay, so what is H2? H2 is f of g2. Okay, what you need to know for composite function is when we do calculation, we start from the inside. We calculate the most inside. So now what we want to know, what is G2? Can you read the table and tell me what is G2, please? G2 is 1. Okay, 2 is here, Gx is here, G2 is 1. Okay, 2 is here, Gx is here, G2 is 1. So the G2 inside becomes 1. So now the new function becomes f1. So what is f1? F1 is 1 is here, f is here. So the value is -2. Okay, the value is -2, this value here. -2. So that's how we work out H2. H2 is -2. H2 is -2. It's just a substitution and then reading values. Okay, read values. So the only thing you need to know is for composite function, you need to calculate from most inside.
In these kind of questions, will you always be given like a table of values?
They can give you functions. They can give you what is fx, what is gx. You can sub the value by yourself and then do that. Yeah. Okay, the next thing is a little bit difficult. So I want to find H2, so I need to know what is Hx. Now I want to find f-1. What I need to know first? Okay, yes. If I want to work out H2, I need to know what is Hx. Now I want to work out H-1. What I need to know? H-x first. I need to know the function first. Okay, your Hx is this. What's your H-x? Do you remember? G-x times f-gx. Okay, that's the formula I give you above, and I tell you need to remember that, and then how we use it. That's how we use it. We have Hx. I don't know what is Hx. I don't know what is Gx. I don't know any information about that. I can just generally write what's the derivative of them. It's in terms of f and g. Okay, it's not a specific function. I don't know the number, so I can just use this to represent. Okay, use this to represent. Okay, what I want to find now is H-1. Okay, H-1. That's what I'm trying to find. This equals to what? All the x will become 1. So it's G-1 times f' of G1. Okay. This is still a composite function. I put Gx into f'(x). What is G-1? G-1 is -2 times f', we calculate from inside. What's G1? Yeah, G1 is 0. What is f'0? -3. So that's a 6. H-1 is a 6. Okay, give you a little bit extension. A little bit extension. Can you express the dy dx for me in terms of f, please? You can still have f. but I want you to express dy dx. I don't know the function of f, but I know that's f of 3x squared plus 1. Can you derive this for me? Use the same formula here, okay? G dash x, f dash gx. Still use the same formula here. Derive that for me. What's the gx in this case? Yeah, so your gx is 3x plus 1 in this case. 3x squared plus 1. Still trying to use the formula, exactly the same formula. What you can give me? What's g dash x? 6x. Okay, is g dash x times f dash of gx, right? I don't know what's fx, so I will just use f dash. So that's 6x times f dash of gx. So gx is still inside. That's your derivative. That's your derivative. In terms of f, you still have f involved. So it's g dash x, which is 6x, times f dash. F dash is just f dash. I can't do anything with it. Of gx. Gx is just what you still have inside. Those two is just two examples, and maybe it's the only two kinds of questions you will use the f dash, g dash x times f dash of gx. That's how we use that formula. Any questions? Yes? Sorry? Yeah, that's part of chain rule. That's part of chain rule. Yes?
So how did you know that this is an f of gx function and not f of it?
Well, because that's not x. That's a function. That's not a single x. If it's fx, it's fx. If it's x, then that's just a single x. If it's not x, it's OGX. It's another function. Yeah, that's the equation. That's the equation. That's a gx. That's not a single x. Except single x, everything else will be a gx.
You know how we're going to compare the second formula that you f of x equals gx?
Yeah. That's another formula.
So why can't we use it here?
Where's the power? Like the second formula is gx to the power of n, right?
Yeah.
Is that in this form? Are they look the same?
Can't you say the power of 1?
There's no point if it's to the power of 1. To the power of 1 is still the same function, it's still gx. Like n needs to be any other thing except 1 or 0. Otherwise, it's not something meaningful. If it's still to the power of 1, it's still the same function. Why we need to use the second formula? Like you need to have something that looks the same way as what is written there. So I have two ways. One way is f of gx. The other way is gx to the power of n. You try to see which one is satisfied, like which one looks the same. If you don't have any questions, the next page is a practice page for you. You can try to derive the next page using chain rule, okay, using chain rule. And if you finish that, you can do some textbook questions.
Is this going to be the exam?
Yes. All of what we learned this week will be in the exam, definitely.
We only have one exam